Hello, my name is Charles Raffaele, and I'm a graduate student at the Graduate Center, City University of New York. Please join me in welcoming Dr. Stephen Farenga of Queens College, the City University of New York, who I have the honor of interviewing today. Thank you.
Thank you. It's an honor to be here.
Could you introduce yourself and tell us a little about your research?
Sure. Dr. Steve Farenga, City University of New York at Queens College. Research primarily in spatial cognition and the development of spatial awareness in children and adults.
Great. Could you describe your program of research and approaches to teaching and how you came to develop these?
Approaches to teaching. I've taught everything from pre-K through middle school, through high school, mostly science and STEM-related courses and education. And I would say most of the things that I've learned in teaching was actually from observing young children and watching young children as they would learn or really play. So basically through naturalistic observation, watching them play, watching the things that they were able to do, usually working with manipulatives or working with some types of concrete objects. And then I had the pleasure of being able to watch those students progress from nursery school basically through middle school and see some of them actually in high school, and really taking a look and seeing which of those primary skills became important for STEM-related learning. And it really came to see that it wasn't just the manipulation of the materials, but how they were relating those physical objects to the abstract concepts that we were trying to teach later. And were the educators actually using the early experiences of some of the children to tie those abstract concepts to? And that became very important in teaching. And taking a look at how materials were laid out, the difficulty in the materials, the design of the instruction. So really we were taking a look at cognitive load and how cognitive load had an impact on the children's learning. But with that, we're really taking a look at their narrowing our focus just a little bit down to spatial intelligence. And the reason why we focused on that is because we considered spatial intelligence to be a primal cognitive frontier on which to work with these children. So for me, spatial understanding and spatial reasoning became primary to learning STEM concepts.
Interesting. Have you found particular findings relating to gender differences in spatial ability that might be influenced with either interventions early on that might have impacts on later STEM involvement?
Definitely, I think what we can see, some of our early work that took place with spatial reasoning and spatial understanding, we basically found that when students at a young age were in an enriched environment, and the environment was basically had the materials and things that they needed to explore with and to learn those concepts, and the teachers understood how to connect the concrete to the abstract. In a couple of our early studies, we found no gender differences, which was very rewarding to us. Okay, so we didn't find that at all. And I was interested in that because some of my earlier work before the spatial understanding had to do with attitude development in young children and the selection of science courses that children would take. And it was very interesting because right down to about grade 2, children were already socialized in a way where they selected, quote, the stereotypical courses for each other, where even the females were selecting more science and math courses for males, males were selecting more for themselves and less for females. And when we now started to look at some of the spatial studies that we were doing and providing those environments and doing the interventions in those environments, we were alleviating a lot of the gender differences. And in fact, we didn't see really any gender differences, which was good. It doesn't mean that in other studies, like in mental rotations and things as such, that they haven't found gender differences, because they have. But sometimes when we look at larger groups and we change some of the parameters of the study a little bit and the variables, it seems that the gender differences go away. And I really don't like to focus on the individual differences, but rather on the strengths of the individuals and the students that we're working with. And I think that's what our research really had to deal with when we looked at spatial intelligence across the lifespan.
Your answer definitely gives us much information about how spatial intelligence interacts with other parts of a child's life and as they grow up. And beyond that as well, how it's important to focus on the strengths and positive aspects that lead to greater blossoming of our children into great adults. Speaking of the development of our upcoming members of society, would you be able to tell us about some of your innovative approaches to teaching?
I think when you take a look at teaching, especially when you're teaching science, much of it is abstract. So when we're looking at certain problems, is there a certain way to break down things, such as in science, a lot of times the mathematics becomes the filter, which filters people sometimes out of a particular field. So how do you take certain mathematical problems and make them as concrete as possible, either by using the manipulatives or being able to redesign or redraw the actual activity itself? So in some of the problems that we were working on that had to deal with percents and things as such, can you take those percents? Do the students even realize what the percent means? What does it mean to be out of 100? Can we then use some type of concrete objects in order to make the abstract as physical, as possible, and to really get down to what children understand and people understand about a topic? So we find a lot of times when working with young children, one of the big topics that they really do not understand is working with place value. And when we're looking at that, what they'll wind up doing for us is they'll give us the correct algorithm. They'll solve the problem. They'll have the procedural knowledge, but they will not have the conceptual knowledge of what's actually taking place in the problem. And sometimes we don't see that until later, although we may have been doing that in second grade. Sometimes that doesn't expose its head again until fourth or fifth grade. And that may not come about until I'm doing a science problem working on percents and working with solutions, and what percent of the solution might be saline, and another percent of the solution, might just be the straight water. And all of these things, just seem to be compounded.
I see. Then how do you help students develop this conceptual understanding?
We develop conceptual understanding by, number one, taking our time when we're learning specific topics. And when you look at whether it's a science curriculum or the math curriculum, there's so much in it, and we're so worried about the standards, and we're so worried about testing, that the teachers just feel pressured to get the answers, teach the algorithm, and move ahead. So what really has to be done is we really need to slow things down, take some things out of the curriculum, and start to drill down to what people really do understand. And I think that's really becomes, the basis. And it's not necessarily the teacher's fault. I mean, even when you take a look now at the next generation science standards, they're a wonderful, I guess you could say, a wonderful opportunity for how things should work. But when you have to have entire books on how to explain what the next generation science standards are, I think you have a problem. And I think you have a problem for the teachers as well. And I don't care how they spatially design, all of the little things to show, what's related to what. It becomes a problem when there's an entire book on it, on how this has to be implemented. Because I believe that some of these things should be cognitively appealing, and they need to be cognitively appealing to the teachers if you really want them to do what's in there, and they need to be appealing to the students if you want them to do that. And the assessment needs to catch up to whatever is going to be the philosophy of those standards. Okay, because right now the assessments do not match what the standards are asking for. So the teachers are actually in a bind. So what I like about the next generation science standards is they do focus on spatial development, spatial understanding, spatial reasoning, which are very important for the 21st century. They're 21st century skills. They're the skills for engineers. They're the skills for physicists, for architects. They're the skills for artists. Spatial awareness and reasoning is a skill for even musicians. So when we say that it's a primal cognitive function, that's what we're talking about. It's so basic to so many other fields, and I think that's what we are so interested in. So right now we're working on a project on cognition and spatial concept formation, where we're comparing non-digital instruction with non-digital instruction with digital instruction to see which of the two areas produce the greatest amount of achievement and understanding for students. So we did this with my colleague Salvatore Garofalo, where we were looking at students' understanding of the DNA molecule. And we had 4 groups, about 30 students in each of the groups. The groups were, I randomly selected the treatment for each of the groups because we couldn't randomly assign them to groups because they were intact classes. So, no school is going to let you, change their entire teaching schedule, for that. And we found some very interesting, there were some interesting findings in that, where students actually that made the paper models of the DNA molecule actually did quite better than students that were using the digital models of the DNA molecule, and they had to construct it digitally as the other group that had to construct it, paper and scissors and putting them together. I think what was interesting is when we looked at the results short term, right after the instruction, within the 4 groups, we had no difference. All the students achieved basically the same. However, when we went out 5 and 6 months with the groups, and we had to have them now come back and tell us about DNA functioning and telling us about the nucleotides and base pairs and things as such, there was no comparison between the 2 groups. In other words, the students that actually learned it with constructing paper models and having to take notes the old way was so far superior to the other groups, where paper instruction really did so much better than the students who actually learned digitally. When we're talking about the students that learned it digitally, as I said, they were using digital models. They took their notes digitally. They could look up anything they wanted. Everything was on iPads, basically. And the other group had the same exact materials, just that they had paper and pencil for the materials. And as I said, the effect size, I think, was about 0.78, which was quite large. Okay, which meant not only did we have statistical differences between the groups, but we also had a very large effect size, which really had some demonstrated practical differences.
Wow. These were great elucidations of myself and all of our viewers' understandings of standards of the next generation as things move on in teaching through this new century as it continues, but also how those standards are communicated, assessment, and of course this study that you mentioned now, which was very interesting in terms of the greater retention by those who use paper and pencil over digital. So now moving on to last question I have for you today. I'd ask if could you provide 3 tips for graduate students who are currently working on a graduate degree?
Sure. Read. write down your notes and do something that you're passionate about. So number one, have a passion about whatever it is that you're going to be studying, okay? Because there'll be many nights when you're by yourself and it's just you and that journal, or you and whatever you're writing, or you and whatever you're thinking about. So I would say the first thing is to be passionate about the subject that you're going to be studying or want to do your research in. Number two, find a group, somebody who likes or enjoys what you do but has a different twist on it a little bit. So if you're doing language, find somebody who wants to do what you're doing, possibly working in an area of teaching science, or someone in an area in art. I found the greatest enjoyment I had was definitely working with other individuals to solve a problem, and not like-minded people. I can get anybody to read what I've written and say, oh yeah, those are good studies in the field. I don't want someone to agree with me that those are good studies in the field. I want someone to look at them and say, but Smith said the following, and he had the opposite of what you're finding, okay? Because I think seeing those differences makes you a better researcher. And the third thing is, try to make whatever you're doing interesting to others. And if you can make it interesting to others, I think that will make people enjoy what it is that you're doing and get you, I would say, the most exposure. And today, exposure is an important thing, whether it's exposure through grants, whether it's exposure to writing. So my last bit of advice is, when you do get that first job, okay, remember something. You write to stay in the position that you've just obtained, and you write to leave. And people always look at me when I say you write to leave. Yes, you write in order so that you can leave for your next job. You never want to feel that you're a hostage somewhere. So that's always my best bit of advice, when you don't have to feel like you're a hostage. And I would say that's really about it. It's a great field. I think research is a wonderful thing. I learn something every day. I enjoy working with people that have diverse takes on situations different from mine. Because I think that's where you really create new knowledge. And I think that's really what it's about. So remember, you not only want to repeat other people's knowledge, but if you're going to be in this field, you need to be a person who creates knowledge and things that other people want to read. And I think that's what makes a big difference.
Great. This is exactly what us graduate students need to hear to be able to get us through.
I wish you all the best. It's a changing field, and I've said some things about technology, and I don't want you to think that technology isn't important. I think technology is really important. It just has to be used the right way. And I think what we're doing today, when you see all these young kids with cell phones and sitting on cell phones, and I'm out to dinner, and they don't even have a conversation with the people that they're with, I think that's where the technology is troublesome. Or students that come up to the board, even in my college classes, and they take a picture of the board, and they think it went from the phone to their brain, and they're going to open that up 2 minutes before I'm giving a test or a final, and say, oh, I don't know where that came from. Where did it come from? So technology is extremely important, being able to use the technology and for its benefit, but also I think that if it's not used appropriately, like anything else, that, as we saw in the study that we did, it really doesn't get you the results that you're looking for. Short term, we got the results. Long term, the results were not there. And I think when we talk about learning things, we're talking about, if it's true learning, it's being able to use it in another situation, somewhere down the road.
Okay. Great. I'd like to thank you very much for the time and attention you've given to answering these questions, and I'd like to wish you the best in your future work.
I wish you the best in your future work, and I hope that your study goes along the way that you anticipate it to go, and you hop over all the hurdles and get there, and I'm sure you're going to enjoy it a lot. Thank you very much.
Thank you.